What we are doing here is OpenRiskNet, presenting OpenRiskNet and also demo that. This is the agenda. Very quick introduction. I hope I can make it in less than 10 minutes of OpenRiskNet. Then we will show, Tim will show the infrastructure. Then I will go back to the case studies, which we are all basing our developments on. And then we have hopefully 2 demos. If not, we just move one of them to the next week if we are not, if we are too slow. OpenRiskNet, I think some of you from the Nano Working Group already saw one presentation of OpenRiskNet. What we are doing there, it's really this idea of bringing existing tools together and then make it easier to combine them, build them into workflows, and in this way give it an easier access to the users to many different things, and in that way also promote new things and give the users a smoother update or way to also try new things, combine new things, and in that way also develop new things. OpenRiskNet is the main infrastructure below, which is then described by Tim later. And on top of that, these existing, or we bring these existing tools in. Our approach was case study driven, that we really, because the toxicology is just a huge field, and if you look at nano, then other things are coming in, more and more things are coming in, and therefore it's so huge that we cannot show everything, but we can show the principal concept with these case studies, and in that way show how people can then bring other things in. Information can be seen on this website. As I already said, we try to integrate existing tools. We are not developing new tools. We are really only integrating one. It's an infrastructure project, and it is open to everything, to all stakeholders groups, and we want to include you as early as possible. But it also is open to all data, all modeling tools which are available and which help in risk assessment. This is our case study framework. We said, okay, we start with known risk assessment frameworks and then try to divide that into small pieces, and then we created case studies around that, but I will also describe that later. Just a very short introduction to the ideas, but perhaps we can even skip that because Tim will go into that in more detail. We are basing that all on REST APIs, on REST services with APIs, which we then annotate semantically to make them a little bit smarter. Then this whole thing is containerized and in that way push to these virtual environments, research environments, which can then be deployed on many computers, your own computers, or we have this one resource where you can play and try it out a little bit. I go over that because Tim is showing that. We try to, as I said, be as broad as possible. These are the things we are working on at the moment, and we hope that associated partners bring more in. But you see that we cover a lot of things, databases, different databases on the right side, but then also tools, predictive toxicology tools. This is a very small thing, but there are many more which we are also working on. This is just a small subset of what we are using, ontologies, and then especially also the workflow visualizations, which then brings in these different tools and brings them together. This is our reference infrastructure. This is what is running, and there you can play around with different tools. Some of them we will showcase today, but there are all others. Some of them we will show next week, but go there, play around with it. You don't have to register, or you register by using your LinkedIn account or other accounts, and therefore there is no huge procedure to get on there. You can just go there and look around what is freely available there at the moment. Okay, this is just two ways or how we see the whole thing. REST APIs are really for somebody who knows how to write programs, or how to write scripts, Python scripts or something like that. And this is the one side of this infrastructure. The other side is then that single applications also have web interfaces. But for me, these are not really OpenRiskNet, because what we want to do is, on the one side, put these tools together into workflows, and this might be some kind of Python scripts. This I will show next week, or it might be some kind of nicely user-friendly workflow tools, and this is what Tim is also presenting next week, how this will work and how then this can be very simple, put together these different services just by click and push some arrows from one side to the other. I will also go into that more in next week, but because the deadline is coming up soon, even if we will probably postpone it or extend it a little bit. If you have tools which you think might be of interest to this infrastructure, we are really happy to work together with you to bring these into the system, and in that way make it more public available, more openly, more visible to others, and also interoperable with many other things. We have some funding in the project which we can provide to associated partners, and therefore when you apply to this challenge and we select you, we will support you on the one side really strongly technically, but also a little bit financially. Therefore, I hope that this is of interest. The deadline is tomorrow, more or less, but as I said, we will extend that, and then there will be two others. Main criteria for us is really that we have something which we don't have already in there. It might be data sources which are really providing a new area of data, or this kind of commercial licenses which we have to run through the system. There are many things which we want to include, but don't have really the tools ourselves to really show that this is working. Therefore, we will select them a little bit in this direction, but in principle, we are open to every suggestion you have for us. Good. That was my quick introduction. We can already have a very short question round.
Thomas, I have one question. My name is Javed Khan. Yeah, great talk. I'm curious to know, will there be any nanomaterial risk assessments with nanomaterials and animal studies?
What we are, you will probably see that Egon is in here. We have one of the, or we will have multiple case studies which are specifically nano. One which we are planning is nano with AOPs, nano AOPs. But if you have data, if you have these animal data of then we are really interested in bringing them in. Nano Commons is in principle a little bit our whatever sister project, or our big large brother, which will then also use our tools or our approaches in the Nano Commons, and there all the nano related data will come in. Therefore, we have this additional interaction with Nano Commons to share this, bringing nano-related data into the system, and also nano tools into the system, and we will build these common use cases, case studies. If you are interested in something specific, please contact me, and we can see how we do that.
Okay, thank you.
Sim, you are now presenter. You will be able to go to Share tab and share your screen. So I'm Tim Dudgeon from Informatics Matters in Oxford in the UK. I'm going to tell you a bit about the infrastructure itself. And obviously, being an e-infrastructure project, the infrastructure is quite an important part of this. The key concept involved is something that we call a virtual environment. Sometimes we refer to this as a virtual research environment, and so sometimes you'll see it referred to as a VRE, but here we're using the term VE. And that is a virtualized computing infrastructure into which we can deploy a number of tools, both ones from the project partners and from third parties, and make those tools run and interoperate within that environment. And the key thing about this virtual environment that is really quite different to many other types of project is that the purpose of this virtual environment is that you can deploy it to your own infrastructures. So basically, it's a sort of a definition of how to create a virtual environment. And once you've done so, you can deploy it to your own physical servers or cloud infrastructures like Amazon or Google Cloud, and that allows you to set up your own environment with your own security requirements, your own computing resources, as much computing power as you need, or as little as you need. And then that can become your own personalized workspace, either for you as an individual or more likely your organization and all the users within that organization. And that's really one of the key things that I think differentiates this project from what you could consider more traditional projects where you just set up a big site and everyone is expected to come to your site and use it. And we already have one of our associated partners who is already using this concept, and they've set up their own. Well, we've helped them set up their own virtual environment within their own environment, and they're deploying their own tools to that, in addition to some of the tools that we're providing. So that's the basis of the core concept around the infrastructure. And so how do we achieve this? Well, we provide the instructions and the materials for deploying one of these OpenRiskNet virtual environments, and all of that is described in GitHub. If you go to that link, then you'll see some quite detailed instructions for how to deploy your own virtual environment, and we'll be expanding this over time so that we support a wider number of cloud providers and different deployment scenarios. But in addition to the ability to provide to provision your own virtual environment, we provide our own reference site, which is what we can think of our master site, our reference site, where the current tools are deployed, and where you can use that to test and evaluate the concept. So the link there will take you to what we term our landing page, which is a list of the applications that are running within the reference site. And just a word of caution, that reference site is primarily aimed towards evaluation and testing. It's not expected to be a production environment where you could be doing your own research. It's fine for evaluating and trying things out. And you can probably do some fairly serious work there, but it's not really designed to be your place. The whole purpose is, the whole idea is that you would set up your own virtual environment for your own purposes within your own infrastructure with your own security restrictions. And a little bit about the sort of architecture of this virtual environment. We're basing this around Red Hat's OpenShift container platform. Which, if you're familiar, you may not be familiar with this. It's based around Kubernetes, which is a Google product, and you may not even be familiar with Kubernetes. But what these are, they are systems that allow you to deploy containerized applications to a computing cluster, And it provides all the mechanisms for deploying and monitoring and managing those applications. So you can think of it a bit like a distributed operating system, an operating system that runs on your cluster and allows you to deploy your applications to that cluster without really having to worry about which individual servers they run on and things like that. It's designed to run at large scale, but it's also compact enough that it can run on just a single computer, even a laptop. And what the OpenShift environment does, it builds on top of Kubernetes. It's really an extension. It adds a lot of the important things that we would need to add ourselves anyway, such as continuous integration, continuous development capabilities, security, monitoring, and things like that. So it comes with those sort of baked in from the beginning, rather than having to develop those ourselves. The projects, everything we use is open source. But OpenShift is a Red Hat product, so if you want to get commercial support, you can do that, and that will obviously be attractive to some commercial organizations. But everything is available to run for free, including our reference site. And in terms of what this means to you, if you want to get your tool incorporated into one of these virtual environments, if your tool is already containerized, so it's already running in Docker containers, then it should be pretty simple to get this deployable into an OpenShift virtual environment. You just need to write some deployment templates, and it's relatively straightforward. We've gone through that with a number of our own applications, and it's definitely achievable. Obviously, depending on exactly what you're trying to do, there are going to be some differences, but it's reasonably straightforward once you've got a containerized application. If you haven't yet containerized your application, then there are good reasons for doing so, independent of this, and you probably want to look into that. But containerizing an existing application, again, can be relatively simple, but it just depends on the exact details of the application, how many components it has, and things like that. You may, in some cases, need to do a bit of refactoring to optimize it, but basically, this is quite an achievable route to go down. So our reference site is running on the Swedish Science Cloud, and it's running in an OpenStack environment. Cloud environment. So OpenStack is an open source cloud environment that you can deploy to your own servers. It's a bit like sort of Amazon AWS or Google Cloud, but it's an open source and it's deployable to your own environment. We're running on top of that, and the production environment runs on, there's a reasonable amount of hardware available there. There's 15 virtual machines, totaling around about 100 CPU cores, and about 200 gigabytes of RAM. And that's quite sufficient for what we're doing at the moment. We may grow that over time if we need. It's easy to expand this. The OpenStack layer is really the sort of the hardware layer, or the virtualized hardware layer. You could alternatively be using Amazon Web Services or something else for that. And the layer above that is OpenShift. So as part of deploying an OpenRiskNet virtual environment, you basically deploy OpenShift. We've got deployment scripts for doing that. It's fairly automated, relatively straightforward to do. And what that does is deploy the OpenShift environment on top of your cloud environment or even your own physical hardware. And that gives you the OpenShift environment into which you can then deploy your applications. And here on the screenshot, you're seeing some of the applications we've deployed. The main thing at the top that's expanded out is our landing page, which is basically a web. It's a website that automatically updates itself whenever we do a commit into GitHub, changing the content of that website. So literally, you just do a commit to GitHub, and the continuous integration, continuous development features of the OpenShift environment push that out and roll out a new version of the website for you half a minute later or so. Other applications you see down the bottom, message queues, relational databases, the single sign-on system we have, so we can hook all our applications into a single sign-on and have sort of centralized control of the security. You can then configure that to hook it into your own user database, which could be an Active Directory or LDAP directory or whatever, allowing you to control and easily manage the applications that are running in your virtual environment. For examples of applications that we've deployed, these are partner applications mostly at the moment, but we're looking obviously to move towards having some third-party applications deploy as well. All of these deployments we put into our GitHub repository. The link is there. You'll see instructions and the materials you need to deploy each of these partner applications into the virtual environment. A simple example is BridgeDB, which is a product from University of Maastricht that does identifier mapping. It was a relatively simple application to deploy. It comes in a single Docker container, and the link, the second link on the page there is the link to the instructions and the materials for deploying it. And that's if you want to look at how to do this. That's a simple starting point. To get an idea for how, what would be involved if you had an application that was somewhat similar. But some applications are a lot more complex. A couple of examples towards the bottom here. Jupyter Hub, which provides us access to Jupyter notebooks running within the environment, and the Squonk Computational Notebook, which is a workflow tool that we'll be talking about later. A visual workflow tool designed much more towards the end user scientist. These are much more complex applications with lots of components. So if you want to get an idea of the sort of complexity you can move to and deploy, then those are good examples to look at. So that's all about deployment. And if we just did that, we'd have a nice range of tools deployed into a virtual environment, and each one could be used on its own. But that's only part of what the project is trying to deliver. One of the key things we're trying to do is to add to that and make these tools interoperable, so that these case studies and workflows we're trying to address can be properly solved. Because very often you're going to have to use multiple tools. In fact, almost always you're going to have to use multiple tools to address these case studies. So making the tools we deploy and the data sets we deploy interoperable is a key aspect of the project. We can't go into it in much detail here, but basically we have a mechanism in place already where we semantically annotate the REST APIs for these applications. And using that semantic annotation, we can begin to use that to get interoperability and to query those definitions to find out more about what the service can do. We do that in basically two stages. The first thing is just to annotate the OpenShift service to say that this service is discoverable and has been annotated. So this is just a sort of hands up to say that this service contains discoverable information. And basically that provides a link to the endpoint, the REST API endpoint with the Open API, or what used to be termed Swagger endpoint that I think Thomas mentioned earlier. It gives reference to that endpoint where you can get the definition, the semantic definition of what that service does. And just to give you a very simple example here, you can query take a step back. There's a registry application as well that's running that is listening for these services, and when they appear, they get queried. The semantic annotations get parsed and put into a queryable database, and that queryability then lets you start doing some more semantic-like queries. And to give a very simple example here, you could query the registry and ask for all services that can predict a log P from a smile string. Or you could run another query that says, give me all services that can convert an inchi into a smiles, or a mole file into a smiles, or whatever. And then given both of those queries, you can then work out that you can actually convert, you can generate a log P from your inchi or your mole file, because you know how to do that conversion. That's just a very simple example of the sorts of things we're trying to do with this interoperability concept. There's a lot more information available. Firstly, about the registry, there's a link there. There's a query tool to let you try out the running queries against the annotated information. There's a link here to the ontological terms that are used to define the semantic description. And there's a guide, a user guide, for how to do this, how to annotate first the OpenShift service and then the Open API service. So if you want more details here, just go and take a look at those links. So this is a very simple example of this in action. It's one of the applications called Lazar, which is a toxicity prediction using read across. You firstly annotate the OpenShift service with this information, OpenRiskNet static services, and then the URL that is the Open API endpoint. Then the registry will go to that endpoint and parse it, and a small part of it is shown in the bottom bit, and it extracts out the relevant information, and that's what these X-ORN- identifiers are. I hope you get the rough idea here. Obviously, there's a lot more detail to this. And you can see both of those examples on the links that are shown there. So that's it, really, for the infrastructure itself. There's some demos we can give that show some of these things in more detail, both the lowest layers, the OpenStack virtual hardware level, the OpenShift aspects, but probably what I think we should just finish with here and then move on is just take a quick look at this landing page. So you've already seen this a bit, but this is our main sort of entry point to the virtual ORN Reference Site. And we've got a number of applications here, some of which we'll look at in future demos. But each of these applications are ones that we've deployed into the cluster, into the virtual environment, and we can access any of these. And what we're looking for now is to find third parties who also have tools that are relevant and want to be deployed in. And we're going to help you with this process, and hopefully your tools can soon become part of this. So Thomas has just shown the Jupyter, accessing the Jupyter notebooks. I think probably we'll leave it here. Ask for any questions and then move on.
Good. Question to Tim.
Hi, Tim. This is Jaqpot again. It's a very exciting talk. You guys are doing some really interesting work. Just a quick question. You mentioned that we can deploy to Amazon servers so that we can define our own security conditions and so forth. Do you provide recommendations on what types of servers that will be compatible with your download?
I think what we can do is give use our current site as a guide, but I think this should largely be driven by the sorts of things you're wanting to do. I think we can give you a baseline figure for what you need to get the system running. But if you then want to do some deploy sorts of applications that need lots of CPU or HPC type applications, and we've definitely got those in on our target, then obviously you're going to need more hardware. If you can deploy databases that need lots of memory, you're going to need systems which have lots of memory. So I don't think we can give you a definitive answer on that, but we can certainly help with some guidelines, I think.
All right, great. Sounds good. Thank you.
Going back to more the scientific side, to the case studies, I already mentioned that we are case study driven. This is just a reminder. I think nowadays everyone is talking about case studies all the time, and it just to show a little bit what it is. It should show some very specific things and not be general. Not a complete answer to a particular question, but it is meant to show that on very nice cases. In many cases, these are specific compounds or nanoparticle area, like whatever metal oxides or something like that. In our case, it's more the case study shows more. It is an application area, and then you can say, okay, we could do a survey of all available software and data which is available for this specific type of or area of research. In our case, we just show that with a couple of examples of data, how to bring data in, and then how to run that with specific software. But the general concept should become clear, because you can then just remove one software and substitute it by another. Our starting point was talking to many people and then looking into the literature, how these workflows, these risk assessment workflows are developed at the moment and defined. And this is just one example, which I think is relatively nice, because it can be used for really structuring now these kind of areas. You have these specific points here, like metabolism and so on, which you can then put into small pieces and build case studies around that, our case studies around that. And this is what we did. We took some areas here, which are marked here with the squares, and then try to build these case studies, hopefully, at least in principle, covering a lot of things like metabolism, that would also then go probably in the nanomaterial. We should think about that as fate and these kind of things, what happened with the nanoparticles, and we describe that. The first one is definitely then this data curation, data collection and data curation. Then we go here into more the toxicogenomics side of things, system biology, grouping, pathway analysis, then the link to AOPs. On the other, then the other side is the kinetics, biokinetics, and distribution, these kind of things, and all these come somewhat together to make predictions or read across. I have these more details to every one of these case studies. I don't go through that because it's a lot of data. This is available on the website, and I will also send around the slides. Therefore, I will not go through all the things. What is perhaps important is the case study leader, which and the tools which we think about. But case studies is also something which we want to work together with associated partners, because I think these are the ways how to get the requirements in, understand what is needed, if that is works, what we are trying to do, and therefore we are really happy to work together with you. When you are interested in one of these case studies, then please contact me or get into touch with the case study leader, and then we are really happy to support you. Thank you for your support. Thank you for your support. I said, okay, the first one is data curation, also in going to semantic interoperability, bring these different data sources together, and in that way make some kind of pre-reasoning. Then we have the metabolism, I already said, which is led by the University of Amsterdam, the Free University of Amsterdam. We have the toxicogenomics, which is a little bit overlapping then with the system biology and the AOP development. Therefore, you will find here similar data sources as in the other ones. We have the kinetics modeling case study led by Revk. Then another, the AOP link, bringing these data together with existing knowledge from literature to develop AOPs, but also then use AOPs for predictions. This is this grouping via biological information, and then the final one is the read across. All these, as I said, I will provide the information on that, and then you can go into these. And these are our starting points, but these are floating things. Therefore, when you see that there is something which would bring in this thing much better than we thought, we are very happy to hear these suggestions and go in and change the work. case study. The other point is also if there is other needs, and we had already the nano data need there. We are also interested in not too many, but a couple of additional case studies if they are really bringing in new aspects into this, or change one of the case studies in that direction. Okay, that was everything I wanted to say about case studies. You can talk ages about that, but for this introduction, I wanted to make it really short, that we also have time for some presentation demos. And perhaps we can already check if Philip can present his tool.
Hi, I'm Philip Doganis from the National Technical University of Athens. I will be presenting you Jaqpot. It's a modeling platform. It is involved in two of the case studies that you saw before, the modeling for prediction or read across, model Revk, and the reverse dosimetry and PBPK prediction case study. So at a glance, the functionality offered is description. It integrates description calculation services, data mining and machine learning algorithms, methods for defining the domain of applicability, experimental design, interlaboratory testing, biokinetics modeling, and dose response modeling. The way this is done behind the curtain is through the use of Swagger. Swagger is a means to simplify. It is through APIs actually, and API is the acronym for Application Programming Interface. This shows. This allows machines to talk to each other and exchange information. In our case, produce models, get predictions, give back and forth data sets. So behind the curtain, machines can communicate, but on top of that, what we will see now is a user interface that has been built and allows us to perform operations in a more user-friendly manner. A first action that we are going to see today is actually train a model. We will use a data set that is known from the nano literature. It's by Thomas Prezine's team, a Gagevitz et al. Publication that involves 10 metal oxides. 18 metal oxides actually. We'll split that in 10 for training and 8 for prediction. So we use that out of the many algorithms which use multiple linear regression from Revk. We have to give some information. I'm quickly filling something in all of them. We choose which input variables we want, which can be all of them, or the ones that were used in the publication as well, which produced the best possible result. It's molecular electronegativity and standard enthalpy information, and the only toxicity endpoint is log LC50. And we will use no scaling, but we will use the leverage method for domain of applicability calculations. We wait a couple of seconds, and what we get a result is this. What's interesting here is that we get something to see and play with as humans, which is something you can do. Well, we will use to do validations, predictions. This is the model web page. It shows us what we need in the model, what we get back. But here we also get a URI. This URI allows us to get specific to get the functionality through the API that we will see afterwards. Sorry. Here it is, yeah. Okay, so we will perform validation of the model, and using the prediction, using the 8 metal oxides remaining, we get, this is what the prediction looks like, and we get the domain of applicability calculations. We can also click on the QPRF report. Another interesting aspect is that we can perform validation of the model, and we get back a report that contains information that is valuable for understanding our result, the R2 squared value according to OECD, the real versus predicted values in the table, and the QQ plot here, so we can also see the real versus predicted values here in the second graph. Another thing, this was the workflow of the Model RX case study, which you see here. We started from a training data set, we joined that with a training algorithm, and together with the parameters that we wanted, we got a model. We applied that to a second data set, and we got back a model and prediction data set. So that's what we got. So for the second case study, we got the reverse dosimetry and PBPK prediction case study. We will be based on the implementation of PKSIM on Jaqpot. PKSIM is part of the Open Systems Pharmacology suite, developed by Bayer Pharmaceuticals. It allows you to go from substance to rat to individual to population. And what we will do here is we will start from a PBPK model already created in the desktop version of PKSIM. It wouldn't make any sense to do that, to try to integrate that in a web application, because it's too complex. And we will provide it with information about how the training was done, what age, height, and weight combinations were used. We'll integrate that PKSIM model into Jaqpot, and as we can see, if we have that, we can input another data set with different age, height, and weight combinations in order to get drug concentration and time profiles. So the way to do that over the Swagger interface, I'm actually cutting to the chase and showing you the end of it. Here is you get, we will use the post model ID method, and we provide the data set, the URI of the data set, and the ID of the model that contains the PBPK information. So we get a response here, and we can query the data set and see using the get dataset ID method. We give the ID here, and what we get here is a series of concentrations for various times. We could also, that is in CSV format, and we can click that and see that in JSON format as well. It contains more information, actually, descriptions, how it was used, about each feature that was calculated. It is much more information, and it may be less readable by the human eye, but it is heaven for a machine, because it allows it to understand better what it is seeing. So I have to be really brief for today's webinar. So please, if you have any questions, we will be more than happy to ask them now or in the future.
Hi, Philip. Yeah, thank you for the talk. This is Javed Khan. I had a question. Are you using any type of artificial intelligence for your training algorithms?
The training algorithms that we offer right now are not really, it's multiple linear regression, partial least squares. It's not something really fancy. But what we're working on is integrating any algorithm that is available. If you would like more information, actually our architecture allows us to integrate any algorithm that has been written in Java, R, Python, whatever, as long as they communicate to us as a REST service, if that says something to you. So any algorithm can be integrated, and we're looking forward to it, actually.
I think
that's interesting. Thank you.
I think since we have 4 minutes left, I think we will postpone. So Jonathan, but I think it's better to postpone the demo to next week. And therefore, we could use the last 3 minutes just to answer additional questions which you have.
Thank you. This is Mary Heiskanen. I don't have a question, but I just wanted to thank you, all of you. Excellent, very interesting presentations.
Thank you. Thank you very much all for coming and for listening, and I hope it was useful, and hope to see you next week.
Okay, thank you. Bye-bye.
Bye.